Hi guys, in this video I want to talk about reaction rates, which we've been experimenting with in class, but I really want to look at the scientific reason for why the same chemical reaction can occur at different rates. So before we get into that, we need to go back and think about the particle model. So the particle model says that everything is made up of tiny little particles. So you might think of these as like atoms, but we could be talking about molecules as well, but just sort of tiny little particles. And these particles are all spaced apart. They're attracted to each other, and they're always moving. And they move faster when the temperature gets higher. So as the temperature heats up, they're actually going to move faster. That's a really important point that we're going to come back to. So everything's made up of these particles. Now, if a chemical reaction is going to take place, then the particles reacting with each other have to collide with each other. So if we've got a particle over here of a fuel, for example, and that's moving through the air, and then we've got a particle over here of oxygen, and that's moving through the air, these two things, in order for them to react with each other, they actually have to basically smash into each other. And when they smash into each other, that's what's actually going to cause the chemical reaction to start up. So if we want to increase the reaction rate, so the speed that the chemical reaction occurs, then we have to increase the chances that those particles are going to collide. Well, how are we going to manage to do that? So there's basically three ways you can do it. You can increase the concentration of the reactants, you can increase the temperature of the reactants, and if one of the reactants happens to be a solid, then you can increase its surface area. So first of all, if concentration is higher, then that basically means that there are more particles available to actually collide with each other. So if you think about a shopping mall, if there's not that many people in there, there's not much chance that you're going to accidentally walk into each other. But if you add more and more people, so increase the concentration, the amount of people in the shopping mall, then there's more chance that you're actually going to accidentally walk into each other and have a collision. And it's the same in chemistry. If you've got a higher concentration, so more of the reactants that you're trying to react together, then there's more chance that they're going to collide. So secondly, if we increase the temperature, then the particles are actually going to move faster, like we said before. And if particles move faster, then there's also more chance that they'll collide. The example here would be if you were in that crowded shopping mall and everyone suddenly started running instead of walking, there would be much more chance that they were going to crash into each other. So it's the same again with chemistry. And then finally, we can look at surface area. So if you think back to your experiment that you did with fruit tingles or whiz-fizz, this really came out. So this is where if we've got a solid that's reacting in particular, then if the surface area is higher, the particles are more likely to come into contact. So in other words, powders react faster than solid chunks. And you can see that illustrated down below here. So I've drawn this on, is like a solid chunk, and all of these little particles in the middle aren't actually able to react with the particles, the red particles on the outside. So there's only a limited number of reactions that can take place with this solid chunk. But if we broke the same thing up into a powder, then all of these particles would actually be available to react, the blue and the red particles. Okay, I hope that makes sense and clarifies things a bit around reaction rates. Thanks for watching.